Now we are excited to welcome Atanu Sarkar, Senior Engineer at Bosch Global Software Technologies. Atanu's extensive background includes embedded systems, IoT, robotics, and machine learning. His innovative approach makes him a vital personality in the integration of AI and technology in critical fields. Today, he will be answering questions across modalities for saving lives, focusing on AI's potential in healthcare emergency response. Please join me in welcoming Atanu on the stage.
So, everyone had your lunch? How was the lunch? I can't hear anything. Everyone is already sleeping, I think. So, how was the lunch? So, is there any working professional here or everyone is a student? Where are you from?
I'm from Bhubaneswar.
Where are you working?
CSM Technologies.
Okay. Anyone else? Where are you working? Okay. Okay. Any more? Okay. So everyone else is a student here. Which colleges? Okay. Other than ITR? Who is from KIT? Okay. Nice to meet you, Kittians. So I am also from KIIT 2020 batch. Any other colleges? Okay. Sorry? Okay. Cool. So we have a mixed audience here. Okay, so let me share one of the work we are doing. I'm currently collaborating with Shomik on a topic. So guys at the back, can you hear first of all? Is it visible clearly? Because there are some demos and stuff. So anyone, like you guys can scan it and follow along with the PPT on the slides. It's available. And once done, give me a cheer, then we'll start. 5, 4, 3, 2, 1. Okay. So, this is a project we too started. I'm Atanu, and that's Shomik Rakshit, and this is like a collaborative project that is going on. A little bit about myself. I am currently a senior engineer at Bosch, BGSW. Also, there is, at Bosch I am currently working on L4 technologies and ADAS. So if anyone doesn't know, ADAS is related to self-driving cars and all. There are 5 levels of autonomy. Level 5 is where the car is fully automated like you see in a sci-fi movie. Currently in the Indian roads and market you would see we are at level 2, level 3, level 1. L0 is where a car is just a normal car without any assistant features. Other than Bosch, there was a open source project I started long back. It was trying to use LLMs and generative AI in the educational space, and now that has converted, and there's a team driving this. We call this Binapani, and I'm currently an advisor in that. Other than that, yeah, thanks for the nice introduction there. I work with multiple topics like embedded system, robotics, AI, Gen AI, and other stuff. And yeah, you can find my coordinates here. You guys already have the slides. Little bit about the other guy. Shomik is currently working at Medicine Biases, and yeah, he's a GD in JAX, ML JAX, and he is currently developing Weave and him. Okay. So this is a very special picture, which motivated us to start this project. This image was taken at the heart of Kolkata, and yeah, the entire work is dedicated to the brave and junior doctors of India who had the guts to demand justice. So, little bit disclaimer before I started. This is an ongoing project, and it is far from completion. A lot of research and a lot of work is still pending. So whatever progress we made, I'm here to share that story with you guys. So exactly what we are trying to solve a problem here. So I have a lot of medical friends, and I see them struggling every single day. The course itself is huge, and even after they are reading the theory for years and years, they until the practical experience is done, people always struggle. So anyone in the house, into biotech or any other related branches related to biology? Or you have your sisters, brothers, or friends, or someone into medical domain? Can I see your hands? Okay, so you guys will be able to relate what I'm trying to say here. So, yeah. So point is, there are a lot of corpus of text and lot of data, medical data, and if you have gone to any doctor or anyone, people have to always memorize a lot of medicine names and everything to do a proper, prescription and stuff. So question is, can we solve this with LLMs or current generative AI technologies? So we already have all the medical books, medical data, all the case studies and everything. So we went ahead and started collecting those corpus of text, and using that we are trying to build a system. But thing is, like with LLMs and all, it's a stochastic model, right? It's a probabilistic model. You cannot always rely on the data that it is generating. So there should be some kind of accountability. So whatever answer the system gives, there should be proper citation, because end of the day, it's a matter of life and death here when we are talking about medical stuff. Also, can we answer the medical questions across modalities? So not only text data, people work with MRI scans, X-ray data. So there are a lot of images involved. You go to sonography and all, there are a lot of sound related or audio related data also. So it goes on and on. I can go on and on. For example, brain scan is such a complicated kind of data, right? It's not a 3D thing, but the way the brain is folded, the tissues are folded, it's very high dimensional data. So yeah, how do we tackle things across modalities is another question. Then can we assist the medical professionals in their work that I was touching upon, right? So doctors have to look up so much information. You go to a diagnostic center. Can we help them in some way? So these are the questions that came to our mind. And also medical case studies, right? For example, after treating you, which drug to prescribe or which follow-up test to be performed. So yeah, this goes on and on. So let's just start off with the basics. Let's try to build a question answering system. So if you see this paper, VLM for bio, in this paper, the conclusion, the author said that we observe that while VLMs are able to perform reasonably well on simple tasks using questions and multiple choice formats and images with natural looking backgrounds, they struggle in complex tasks, setting that practically more relevant biases. So what it says is it does a very bad job when we come to a medical domain, right? You can ask a simple question to ChatGPT, you would get an answer. But when you need a proper citation on a very complex medical case study, the LLMs wouldn't do a fair justice there. So also LLMs suck at citation, as I said. So kya kare फिर? What to do? So one approach could be using RAG. So anyone in the house who has already worked with RAGs? Okay. What did you guys build? Any one or two?
Chatbot.
Okay, chatbot. Anything more? Okay. SQL database query. Okay. Anything more? Okay, recommendation system. Cool. So, rest of you, have you guys heard of RAG? Okay, show of hands who haven't heard of RAG at all. Nice. Okay, so this is the audience I want. So let me give a very brief about what is a RAG. So the answer lies in the terminology itself. Retrieval. Retrieval means you are fetching the data from somewhere. Okay. Augmented will come to it. Generation means any LLMs you take, what do they do? It's a next word or next token prediction problem, right? So you have a series of texts and tokens, and you have to predict the next token. So that is generation. What if we can bring the actual truth or ground truth or corpus, text corpus down from an actual book or some medical document, and we augment it during generation? So that is what RAG is in very simple terms. Let me slowly explain you what it is. So we have textbooks, research papers, medical docs and everything. So we take that, since it's a long text, right? The text can go, paragraphs and paragraphs. All the LLMs has something called context length. Who knows of context length? Anyone have it? So, yeah, tell me what is context length? Okay, yeah, you said it correctly. So the LLMs can take certain length of input. Beyond that, it won't understand. Similarly, when it is outputting also, there is a context length. So what we do is we take the entire text corpus, we break it into small parts. We call it chunks. So we do the chunking, and each chunk should be done cleverly so that they are related, right? You cannot take the entire paragraph that speaks about 2-3 things. So you do it properly. There are a lot of encoders available. So what is encoding? You take those chunks and convert them into a vector. So everyone knows what is a vector. Come on, you guys are engineering students here. So I'll give you a very brief example in a 3D space, because human brain can only understand 3D. Imagine you have a 3-dimensional space, and each data point you plot it in this space. Imagine in this entire auditorium you just plot things out there. So you would see, imagine I am plotting all the fruits, vegetables and birds, cats and dogs. So you would see all the fruits would come together in a similar place because they are similar. Similarly, maybe the animals and all would be getting clustered in a different area. So what we do with those text chunk is we convert them into vectors, that is the encoding process, and we plot it out into a n-dimensional hyperspace. So instead of 3D, you have maybe say 5,000 something, or the vector length goes very high, depends on what kind of encoders you use. Now, interesting thing is, if you ask a question, that question will also have some certain keywords in it. If you apply the same kind of transformation, same kind of encoding, then you can find a cosine similarity. So let me come to that. Yeah, so this is the retrieval part of thing. So you ask a question, your question would contain those particular strings. So when it goes through the same encoding process, it will also lie somewhere in that n-dimensional hyperspace, right? Now take that point and with the other points you do a Euclidean distance calculation. It can be a cosine similarity distance or any kind of distance calculation. And then you plot out the other points that is near to your question. When you do that, you can pick up the ones that is closest to your question and you take it back. You feed it back to the system. Definitely that text chunk is somewhere related to your question. That's how, in a very basic sense, it works. You do a proper lookup, you retrieve that text, and then you calculate based on the question. And yeah, that's how you get the retrieval side of the RAG. Now coming to generation. So what is a generation? How many of you have tried, in your assignment, dumping the entire question to ChatGPT and getting the answer? Raise of hands. Okay. How many used it in today's quiz? Everyone would be quiet. Yeah. But we all know what is prompt, right? Just asking a question to a LLM, and based on the question, it keeps on chunking out the next tokens, and you get an answer that somehow, we still don't know. We are getting into the explainability of AI, but somehow that matches with the actual answer. We don't know if human brain works like that or not. But yeah, there's something called emergence in physics. I am also a physics lover, so I get philosophical sometimes. So there's a concept of emergence, and some basic rules can come up with a complex output which we don't realize. How many of you know Convoy's Game of Life? Anyone heard? Any CS students in the house? Convoy's Game of Life? Okay, please look this up. It's a very interesting thing, but let's not deviate. So now, during asking of that question, if you take that retrieved chunk and then embed it as a prompt, and then you tell the LLM to nicely form the output, it will give a very good answer, which would be having an actual citation with it. That's the very fundamental, and that's what is a RAG in very simple terms. So this is from the demo. So we asked our system what is a ribosome. It did a proper fetching of the data. We work with Gray's Anatomy actually. So there are a lot of books the medical people has to go through. The first semester they start with Gray's Anatomy. It's about anatomy. So we took that book and then we chunked it out, and based on the question we were retrieving that text back, and then the answer comes and you see it's a very good answer with proper features and everything, and it also gives citation here, that page 35 from Gray's Anatomy. I'll show you guys the weave trace actually. So while developing this project, we use something called weights and biases, and that comes up with nice features. So what we have used here is weave. It's a tool that helps you trace everything end to end. So let's take a look here. So to the left, if you see, this was our function that is written in the code. So this is a class that has a function called predict, and if you see here, the question was what is ribosome, as I showed you, right? And let's take a look in nice markdown. So this is what it gave the answer. This was the final answer. But let's take a look how it reached this conclusion. So internally it called three other functions here. You see made CPT retriever. So I already spoke about retrieval process. That's exactly what's happening here. If you see here, you can see top K, we have taken top 2. So as I said, you have the cosine similarities and all the points fetched. So we are taking top 2 of those points. And you see the first point, it gives some document and some particular paragraph from that book actually. This is directly coming from the book. And then this is the second one, and this is the, again, text coming directly from the book. So weave lets you trace everything that's going on with each of your function calls here. And we are not stopping at this. So how would this be a multimodal problem, right? If we are just working with text. So what we did is, we also stored all the figures, diagrams and images that we found from the book. So if you see here, there's a figure annotator, another class. So inside that, we have this function call here, and each of the diagrams that we found. So first of all, the text is brought back. The top two text is chunk is brought back from the book. Now we know the page number. So this function is taking those page numbers and then seeing if there were any diagrams in that particular page. And each of the diagram has a nice figure annotation. Any book you pick up, below the image would be a nice text that is written, descriptive text. So it is doing that exact same thing here. Okay. Yeah, so it found figure 1.4, 4.4 and all, and it took the, the description here. Let me, just a minute. Yeah. Yeah, so the text that was coming, you see here, so this was the book actually, and then it pulled that entire book out and then it was finding diagrams from that book. And below the image, this text was there, which it was nicely pulling it out. We tried multiple models here actually, and we even tried Gemini models, but sadly Gemini did not do good here. So we had to rely on something called MateCPT. It's a good model. I'll get into the details a little bit later. But yeah, the response that it was giving, it was a normal text and we wanted in JSON. So what we did, we again did a third model call here. We sent that text to GPT-4o and told it to give it in a pydantic format or a nice JSON format that can be consumed. So that's the third function call here. And end of the day, yeah, sorry, I can't expand this. Not sure if that's the internet. Yeah, finally. So LLM client.predict. So this is the third one, as I was saying. Here we are using Gemini. So we brought that entire chunk, the figure description and everything, and finally we are giving the entire thing to Gemini and saying that you make a nice answer out of the entire text that was brought. And the end result you guys already see it here. Okay, let's move on. Yeah, I would also like to cite here, there was a course, RAG++, taking RAG beyond POC from Weights and Biases. You guys can check it out, it's a free course. And we heavily used codes from this course. So feel free to do this. Anyway, just stick to the QR code, you guys have the entire PPT with you guys. Okay? Yeah, let's take a look at the demo. So you see the entire app is live here. Let's ask it some question. So it's doing whatever I just told you guys and explained you guys. It's doing the same thing and it's running and it will give the answer. Let's see what it does. Yeah, see? And then this entire run that happened, I can trace it in Weave, but yeah, you guys already saw that. And it is also citing it, that it's coming from page number 35. So you can blindly trust on this data because it is coming from a proper medical source. Okay, moving on. But yeah, that means this is the repo, you guys can check. The entire code is available here, made public. And also, let's take a look at the docs. So I'll quickly give you a brief of what models we used. So for example, we used the document loaders. So this was a very big struggle. Like reading from PDF is very difficult. Some PDFs are formatted in such a way that the text was not coming properly. So yeah, AI and ML sounds very interesting, but 90% of the work is collecting the proper data. And yeah, we had to also go through the same pinpoint, coming out with the text from that data, that particular book. And if you see, we have used multiple text loaders like PyMu PDF for LLM, then PyPDF2, marker. So these are various ways to extract text data from a PDF book, specifically Gray's Anatomy. And image loaders also, we have tried multiple Python dependencies here. And then I already spoke about chunking. You see what's going on. Everything is in detailed documented. Retrieval also, we tried many things. We tried VM25 sparse, Colpally, and made CPT. So this was performing the best. So for the demo, I selected that. And finally, the assistant side of things also, we have LLM clients like things from OpenAI, things from Gemini. But everything is available here. You can go through this. And finally, that being said, a lot of research is left. We just started off this project, and I think we'll continue the same. Huge things has to be achieved, and a lot of research also has to go through. Here are the acknowledgements. As I mentioned, there were a few papers also. The citations are here. We use weights and biases again they provided us with Gemini, Mistral, and OpenAI credits. Rishiraj, another GD, he helped us with some insights while we were building the vector indices. And here are two friends of mine, shout out to them. They are doctors from Kolkata, and I have been in touch with them while working on this project. And they gave quite good feedbacks actually. So yeah, thanks. Any questions? I will take questions. Come on. There is no silly question.
But the problem was in this, I saw you implemented the front end was streetlit, I guess. So how did you store your session memory or chat history? And what about the context part?
So the entire project, every code we wrote it from scratch. We did not depend on something like Llama Index and LangChain and all those. We haven't used any of those. Everything was written in scratch. And this project currently you see, it's a single question answer. It doesn't remember the history as of now. So we also have that in the pipeline, and then we will need the context and caching and all those storing and stuff. Yeah, at the back, I'm impressed. People at the back were listening.
What good way to integrate contextual memory in these scenarios? Like, for example, I want to explain point number 3. So, how should we store the previous response so that it can again query back that particular?
So, yeah, it's a very good question. And LLMs are a stochastic model, right? There is no science to it. As of now, LLMs, there is no science to it. All you have to do is hit and trial. So you already saw the weave traces, right? There were billions of them. So we continuously improved the prompt templates. We worked on them, saw the answer, we were not happy. We got back, again improved the prompt template. Also, the chunking, like how much should be the chunk length, that also we played on. Sometimes it was a big chunk, it was a small chunk. Based on that, sometimes the data was getting diluted because it was a big chunk of text that was coming, and based on that the answer was getting diluted. So there are a lot of variables, lot of parameters. You have to keep playing with it, and it's an experimental field. You keep on doing unless you are satisfied, and you cannot ever reach 100%, right? Even if you are 90% satisfied, you move on to the next thing. So that's the only way to do it. Does that answer your question? Go.
Regarding the particular context. So, for example, I asked it about something related to hypothalamus, and then I want to dig more into the details of the structure, and I want to refer hypothalamus itself, but I have not explicitly mentioned in the conversation. So, how will it understand the context in a RAG application? That's what I'm particularly interested.
So, while we were fetching the chunks, we had that metadata stored. Every place where it was coming, if you see the weave traces, again these are all made public actually. We'll see we are storing each and every metadata, and based on that we are making inferences and that from which part it is coming. So that's the only way to do it. I hope that answers. Perfect. Okay, any more questions? That side.
My question is moreover regarding like your work professionally. Like you have said that you work on the ADAS system and the embedded system. Like right now, I want to know whether you are sending those data on the cloud or it's on edge computing.
Okay, so currently Bosch, I'm working at Bosch, and Bosch keeps all its data internal, so it's not made public. And there are various scenarios and various kinds of data when we are talking about. So in ADAS, when you are evaluating some or running something on a ROS back, I hope you are getting what I'm saying. So on a ROS back, we run the simulation because you cannot run the car on the road and it crashes or something happens, right? So everything has to happen in a simulation world. So we take that entire E2E architecture, we break it open, and each part we try to simulate. And in lab we try to iterate over those processes. So very briefly, if I speak about it, there are Viper domain, the video perception, sensor fusions, the actuations, how the brakes and everything it will communicate with. So each part is taken care. And while those runs are happening, there are various kinds of data and generated, right? We have our internal file format for that. And yeah, we have some storage, internal storage, which is not made public. I hope that answers. There was a guy at the back, he was, yeah, this side there were some questions. I saw raise of hands. Any questions?
So my question is regarding your chatbot. So working in a medical field requires many kind of certifications and there are many restrictions. So how you deal with that? Because when you use a chatbot, they learn they use machine learning. So how the data are verified?
Okay, another good question, but we haven't reached that end that we will go for some certification. As of now, I am collaborating with my friends who are doctors and certified doctors, and they are giving feedback. We have a lot of aim and plan with this project, but as of now, we are trying to get some data that would help a professional, not directly used in an emergency situation. But yeah, that's in the pipeline. When we go there, definitely we'll figure something out. So stay in touch if you are interested about this project. Yeah.
Yeah, so my question is that how is this generative AI different from the other generative AIs? Because already even if we use ChatGPT or Gemini and we ask the similar question, like just now you asked about the ribosomes, okay? So even that will give all the answers. Then how is it different from the other AIs?
So our LLM is, as I said, it's a stochastic model. It's a probabilistic model. So only way to deal with it is instead of asking one single question, getting a random chunks of tokens out, we have built a system here where multiple models who are based in their domain, right? Some models are good with images, some models are good for only text, some models are good with text and images, right? So based on that, we have broken that down into an architecture, and those parts, it's communicating, getting the data back, and it's again taking that, retrieving that data, and again another prompt, through another prompt template, it's making another call. Some subsystems are taken care by other models. So by distributing things, and if you are giving a very easy job or an easy question to an LLM, it would give somewhat 90% accurate. Like again, I don't want to quote on that number, but by breaking and distributing it and making a system with multiple LLM calls with multiple models, we can at least make things better. And as I said, there's a thing called evaluation, which is important. So that's in the pipeline. We haven't completed that yet. So there are ground truth, right? We can go to the medical professionals and say, if this question was asked, what was the answer? We can go and see at the maybe NEET papers and all, like how the questions and what is the correct answer. Based on that, we can build an entire evaluation system which can judge our entire system and tell and give us score. So that's the process. Yes. We are already working on the evaluation pipeline. Since it's not complete yet, I haven't included. Can I take a few more questions, organizers? Okay. I take 3 more questions.
So my question is regarding as the chatbot has medical knowledge only. Yeah. So as your chatbot has gained knowledge gained from your medical friends, so do the chatbot answer those questions regarding the disease or someone having some kind of symptoms?
So as of now, as I mentioned, we have used Gray's Anatomy. It's like a Bible or encyclopedia for anatomy only. With talking to my friends, I understood it's a huge, lot of semester papers on different things. As of now, for Gray's Anatomy, it is doing good, but after we implement the evaluators and all, we'll get to know better, much better.
So basically, it contains only the anatomical part, right? But when it comes, because we have some many surgeries like open heart surgery or maybe ear surgery or something like that.
So what you are hinting towards is agentic workflows. So based on retrieved data, we can have function calling to do something. Like imagine such a case came and then it might suggest that go and do that X-ray or something. So that's already in plan. It can be implemented by action calling and function calling and all. We already have that in the pipeline.
Yeah, sure.
Yeah.
You told that you did not use any frameworks. You told that you did not use any frameworks. From scratch you did. Why?
I mean, it's better to trust our system than get into a black box where we don't know what's written inside. So we have already worked with such systems, and this entire project we wanted to write it from scratch for accountability, because this system should be reliable. So we know every piece of code that we have written. That answer I hope.
Can we integrate OCR with RAG? For example, if a doctor diagnoses a person and there are different doctors with different ideas. So if we are the receipt is uploaded in the system chatbot, it will give the all information.
Yeah, so I think there was a Google product. I saw it in the Google I/O this year only. So handwriting of doctors is very difficult to understand, right? And I think Google is also working on that. There's a product on the lines and it could accurately predict what was written in the prescription. But yeah, with OCR and all, we can have it as a function calling also, and then inject it as a question to this particular system. We also have that in the pipeline. Yeah. Any other questions? Feel free to connect with me. This is my coordinates. In any social media, I'll be found with this username. Feel free to follow Shomik also. You guys already have the slides, and just put the QR. Yeah, thanks all.